In this lesson, we're going to start talking about how we can reduce rational functions. And the key for recognizing for how we reduce or simplify rational functions is to know that we can only start reducing or canceling out things when we actually have to have the factored form. And it might not be very obvious when we work with fractions with only numbers without any variables, because for any time we're canceling out common factors in a fraction, we call them common factors because these numbers are part of the product over here. And that's the same principle we want to apply to any rational functions. Anytime we want to reduce rational functions, we always have to have the factored form fully first. And if something starts with a factored form, we can directly use that result. If things are just coming in standard polynomial form, we'll have to do factoring first, using all the strategies we learned in the factoring section. And now looking at some of the examples for part A, we see that this is already factored over here. We don't have to do anything to it, or we don't have to do anything to factor it anymore. So once we have things in factored form, in order to write it, we would just say f of t, and that's equal to, we have these two factors canceled out, which is equal to t minus 10 left on the bottom. And just like anytime we cancel out a factor in the fraction, we would just have 1 as the placeholder over here, because t plus 7 divided by t plus 7 is equal to 1. Now moving on to part B, we see that these two expressions on top and bottom of the rational function are not in factored form, so we'll have to go ahead and factor that first. So for the top, we have t minus t squared. Remember, the first step for factoring is always checking whether we have any greatest common factor. Here we can factor out t over here. And once you do that, we would have 1 minus t left in the parentheses. And in the denominator, we want to get a result of two binomials, a product of two binomials. We should have t and t, and then we want to think about two numbers that multiply to be 5 and add up to be negative 6. Because the sum is negative, that tells me both numbers has to be negative, and I get minus 1, minus 5 over here. And when we have this result over here, one thing we see is that we have 1 minus t and t minus 1. If you are not aware of this yet, it's a good trick to remember when we have binomials like this, when the order of the terms are just switched and it's a subtraction in between, they're exactly negatives of each other. And you can also take one extra step just to make sure things are in a easier to see order. So here on the top we have 1 minus t. We know this is not in decreasing order as we normally would write it, so we can also factor out a negative sign from the leading term. So the leading term is negative t. If we do this, we would have t times, and just from the 1 minus t, if I factor out a negative 1, then positive 1 would become negative 1, and negative t would become plus t over here. And then let's keep the denominator. Now it might be a little bit easier to see once we simplify this over here, that we have t times negative 1, which is negative t, and negative 1 plus t is the same as t minus 1, all over t minus 1, t minus 5 in this case. And then we can do the cancellation. And alternatively, you can also see this t minus t squared over here as not in decreasing order, and start off just by reversing the order or switching the order of the terms first. And I'm going to show this as well as an alternative way to recognize that we have some cancellation to do. And to do this, the first thing we can start with is to put everything in decreasing order on the numerator. So that becomes the first step we do. That negative t squared plus t is indeed what we have on the numerator, and on the denominator we have t squared minus 6t plus 5. So now if we look at the numerator, we can again recognize the leading term is negative, so I can factor out a negative sign along with GCF being t. So once I do this, I will have negative t times t minus 1 all over t minus 1, t minus 5. So no matter which method you use, as long as you recognize that we have a cancellation on top and bottom, that's what's important. And either way, you'll land to this expression where we have t minus 1 to cancel each other out, and as a final result, we would get negative t over t minus 5 over here. So just choose whichever way makes sense to you. Once you recognize 1 minus t and t minus 1 are the negatives of each other, that's a key point here. And now for part C, h of r again doesn't have the top or bottom in the factored form, so we'll have to do this our own. And on top we have to use AC method to test out, and a times c in this case is equal to 15, and you can actually recognize that we would indeed have a result of the two numbers that works, and we want the sum to be 8. So that tells me I really have the numbers being 5 and 3 that would work, or positive 5 and positive 3 that would work. So we can rewrite the top to be 5r squared plus 5r plus 3r plus 3. And now if we want to keep factoring the top, we would want to group things together. The first two terms and last two terms go in their own groups and connected by addition. Now on the denominator, we can again practice the idea that we can reverse things in orders and have everything in decreasing order, which becomes negative 6r squared minus r plus 5. Make sure you carry the signs correctly. The signs in front of each, at the beginning of each term, indicates the sign of that term. And now looking at the top, we can do factor by grouping. In the first group, the GCF is 5r. We're left with r plus 1. In the second group, the GCF is 3, and we would have r plus 1 left again. Now on the denominator, since the leading coefficient is negative, we can factor out a negative sign, and that becomes 6r squared plus r minus 5 in the denominator. Moving on to the top, we would have r plus 1 as a common factor to take out, and left with 5r plus 3. On the denominator, we would want to do the AC method again, and I'm going to put the negative sign in front of the entire rational function just so I don't have to worry about this later on. And that's the negative sign I carried from the denominator. Now in the denominator, I have this AC method to use. Here I have my a times c to be equal to 6 times negative 5, which is negative 30. And I want the sum to be equal to 1. And again, if you list out all the factors that would work, these two numbers should have opposite signs. We should get positive 6 and negative 5. That would work. So I'm going to rewrite the parentheses part in the denominator to be 6r squared plus 6r minus 5r minus 5. Again, I only need to worry about the parentheses part in the denominator because I already moved the negative sign in front of the entire expression. And based on this, we can do factor by grouping on the bottom as well. First, I'm just going to copy what I factored already on top, so the top is all done. On the bottom, to do factor by grouping, the first two go together, last two go together, connected by addition. And as a result, the GCF for the first part is going to be 6r, and I'm left with r plus 1. Second part, we have the leading term being negative, so we can factor out negative 5 times r plus 1 over here. And to put everything together, we have negative r plus 1, 5r plus 3, all over r plus 1 in the denominator is a common factor, left with 6r minus 5. So altogether, r plus 1 is a common factor, and we should get negative 5r plus 3 over 6r minus 5 as the final result of this simplified function.